Assalamu alaikum students. My name is Nahid Sultana Upama. As you all know by now that I am conducting your Environmental Engineering 1 course, that is course number 3 CE 341. And today the topic I am going to be conducting is water distribution system. These are basically the book references that I have used to make this lecture. You can also go through them, and these are the content. The content we are going to study today are water distribution system and water distribution methods. These are the learning outcomes that you will get after the completion of this chapter. Okay, so first of all, we all have to know what is actually a water distribution system. Here in the picture we can all see that there is a source, a treatment plant, and a water distribution zone. There is actually two zones. Okay, here we can see from the source we get water, but the water we get from the source is not completely pure. There are many microorganisms, the dirt, and many particles which are not desired when we use the water. So to get rid of those particles, the water needs to be treated. So what to do? The water will go to the treatment plant. After being treated in the treatment plant, then the water will go to the distribution zone, and this is actually the distribution system. This whole system is called the water distribution system. If we go by the book's definition, what is the water distribution system? This is like the distribution system is the part of water work which receives water from pumping station or by gravity flow and delivers it throughout the district to be served. What is actually pumping station or by gravity flow? We will be learning this when we proceed in this lecture. Okay, the purpose of water distribution system. Why actually we use the water distribution system? Water distribution system is designed adequately satisfy the water requirement for a combination of domestic, which is our household needs, commercial, which is actually the office, the water needs in the office, and industrial, the water that is needed in the industries, and firefighting purposes. When any fire break out in any area, to remove that fire we need water. So this is the firefighting purposes. Water distribution system is needed basically to satisfy all four needs. Okay, then the qualities of good water distribution system. What are actually the quality of a good water distribution system? When we will call a water distribution system a good one, okay, there need to be adequate water pressure. Water pressure needs to be adequate at the consumer taps for a specific rate of flow. Pressure should be great enough to adequately meet the firefighting needs as well. At the same time, the pressure should not be very much excessive, because the development of pressure, it cost consideration, and it also increases the pressure. If the pressure increases, it also causes leakages. When the water pressure is more, it causes leakages, so it will be a loss of water. Then the sign of a good water distribution system, that it will be completely watertight. Watertight means that there should not be any holes or any chances, so that the purity of the distributed water should be maintained. Then the maintenance of the distribution system should be easy and very economical, because if it is difficult, it will not be handy for people, and if it is not economical, then the majority of the people will not be able to get the benefit of the distribution system. then the layout should be such that no consumer would be without water supply during the repair of any section of the system. That means if any section of the system goes out of function, then in that particular area the consumer should not be deprived of water. The design should be like that. Okay, the means of water distribution system, how water is distributed. Water can be distributed through canals, tunnels and pipelines. It actually depends on the topography relationship between the source of supply and the consumer. Source of supply is from where the water is collected, and the consumer is us, where we get the water, actually the distribution zone. Okay, now the water distribution method. Depending on the level of source from where water is collected, the topography of the area and local conditions, water may be forced into distribution system by these three ways. These are actually the three ways by which we actually distribute the water. These are the gravity flow system, direct pumping system and combined gravity and pumping system. Okay, now it's time for brainstorming. When do you think gravity flow system is suitable? I have here blocked the word gravity. That means I have given emphasis on the word gravity. So please think and then write in the discussion forum that what do you think, that what will be the correct answer. If I may now discuss the gravity flow system, your answer will be clear, that you will be know that if you have written the wrong answer or the right answer. So this is the actually gravity flow system. Here is the supply source, that means from where the water is collected, and this is the service area, that means the consumer's area, where we live, where we get the water. Supply source is in the higher elevation and the service area is in the lower elevation, lower place. As I have already told that I have emphasis on the word gravity, that means the water will be delivered through gravity. That means the correct answer is B, when the source of water supply is in a higher place. Here we can see the source of water supply is in a higher place and the service area is in the lower place. Okay, from the supply source, the water goes by gravity flow to the treatment plant, and then it goes to the service reservoir, which is actually a storage where the water is stored for a time being. Then from there it goes by gravity flow to the service area. It is basically the whole gravity flow system. There are basically some advantages and disadvantages of every system. The advantages of gravity flow systems are it requires no energy to operate as water is conveyed by gravity. Gravity is a natural phenomenon, so there is no energy requirement to operate this system. No pump is required and there are very few moving parts. Construction, operation and maintenance are very simple. What are the disadvantages? It is not applicable in those countries where an elevated source of water supply is not available, and water loss by leakage and wastage is comparatively higher as the system remains under constant pressure. Why? This is because gravity is a natural phenomenon, so we do not have any control over this gravity system. So the water loss by leakage and wastage is always happening and we do not have any control over the pressure, so it is actually a disadvantage. Then going forward to the direct pumping system. Direct pumping system is actually the opposite of the gravity flow system. Here the source is actually in the lower elevation and the service area is in the higher elevation. Here we can see that there we need a pump, so it is called a direct pumping system. This is why it is called a direct pumping system. From the river, that means the source, water is pumped to a treatment plant, then after treatment it is pumped to a service area. But there is actually, if we notice that there is actually no reservoir needed or used in this direct pumping system. That is why it is called direct pumping system. There is no chance of storage of water. It is suitable for small community water supplies because there is no storage. So if there are many people, it will be difficult for them as there is no storage of water. There is also some advantages and disadvantages. These are like, water can be pumped when required. As pump is a machine, we can operate it whenever we want. So water can be pumped when we require it. Low water loss due to system leakage. Okay, because it is a machine operated, we can actually control the flow or control the pump, so there is low water loss. Disadvantage. What are the disadvantages? Direct pumping at a uniform rate is not able to meet varying water demand. Okay, varying water demand, but what do I mean by varying water demand? In some parts of the day the water demand is very high. For example, in the morning people take shower or cook, or in the noon when people cook, the water demand is very high. But during the night time the water demand is not that much high with respect to the daytime. So direct pumping is occurs actually at a uniform rate. This varying water demand cannot be met by this uniform rate. It is very difficult. Then a power failure means breakdown of the whole system. It is actually the whole system is interconnected, so a power failure, because of a power failure, it will cause a breakdown of the whole system. Maintenance and operation costs are high, obviously, because there are pump involved, energy involved, so cost will be high. Inflow of water through leak may cause water contamination during non-pumping hours. When there is no pumping happening, inflow of water, there may be some leaks, and inflow of water through those leaks may cause contamination of water. So that will be a very dangerous disadvantages, because we do not want contamination of water. We all want pure water. Okay, then coming to the combined system. From the name itself we can tell that it is the combination of the gravity flow and direct pumping system, and we can also see that here we can see that it is mostly like the previous direct pumping system, except one change, that is the service reservoir. Here is the service reservoir. The river, that means the source, is in the lower elevation and service area is in the higher elevation. If from the river the water is pumped to the treatment plant, and from the treatment plant there is actually two things can be happening. If the water is pumped to the service area directly, then it is the direct pumping system. But if the water is pumped to the service reservoir and then it actually goes the water goes to the service area by gravity flow, then it is the combined system, because there is the gravity flow, the action of the gravity flow, and also the action of direct pumping. So it is actually the combined system, and it is actually the most common system. There is also some advantages and disadvantages. Basically it is the most common system because it is more effective in most of the cases. The advantages are the system is more reliable and cope with the fluctuation of water demand. As there is a service reservoir, we can actually store the water for later when the demand is high. So it is reliable and cope with the fluctuation of water demand. The pump can be operated at rated capacity, resulting in the high efficiency and economy operation. Okay, the pump can be operated at rated capacity. That means according to the demand. When the demand is high, the pump can be operated at a high rate, and when the demand is low, the pump can be operated at a low rate. Then reasonable pressure can be maintained with varying water demand, and there is no possibility of inflow of polluted water in the system. As there is reasonable pressure, so the water reasonable pressure, so there is no chance of any inflow, and thus water will not be polluted in this system. Now the only disadvantages is actually its cost. It has relatively higher initial cost because it includes both the pumping and the reservoir. It goes like the বাংলা অ্যাডভার্টাইজমেন্ট লাইক জিনিস যেটা ভালো দাম তার একটু বেশি. Okay, jokes apart. Now moving on, cases where combined system is used. Combined system is basically used in different cases. In most of the cases, because it is very convenient, I will show you 3 cases like this. Case 1 is when 2 sources of the water are used to supply water. There will be actually 2 sources. One source, this is source 1, is in the elevated higher elevation, and other source is in the lower elevation. So naturally the source that is in the higher elevation the water will be generated by gravity or directed to the city by gravity, and the source which is in the lower elevation, the water will go to the city by pumping. Okay, case 2, in the pump system, sometimes a storage elevated tank is connected to the system. Here we can see a source is connected to the elevated tank. Okay, when the water consumption actually low, then residual water is pumped to the tank. Here we can see that when the water consumption is low, then the water is pumped to the tank, low consumption of water, and it is then stored in the elevated tank. And when there is high consumption of water, that means that the demand is very increases, then the water flows back to the consumers by gravity like this. Can you see that? I hope you are clear about that. Okay, now moving forward to the case 3, when reservoir is in the between the source and the consumer area. Here we can see that a reservoir is in the top elevation of that area. From the source, it is water is goes by pumping to the reservoir. The water is stored here, and by gravity it then goes to the city by gravity. So it is actually a combined system. This is all about the lecture about water distribution system. If you have any question, please put it in the discussion forum. I will be happily answer it. Thank you for the concentration.